Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is a follow-up to the previous video in the series. We were creating the tone generator, finally, and now we want to add some more features to it, so let's jump right in. We have here the source code for our plugin, and the plugin is right here, and here is the oscilloscope in which we can see the shape of the wave that this is generating. And of course, master is muted because we don't want to blow anyone's speakers. So the first thing I want to do is to add a phase shift to each of the different shapes. And we talked about the idea of phase before when we were developing plugins that would invert phase and whatnot. The main idea here is that we can combine the shapes, and since we are muted, I can bring this up and then we can see it bigger. And when we have two shapes at the same time, they interfere in some different and interesting ways. So we have a sine wave and I bring in the square wave and it goes like this, which is an interesting thing for it to do. But I would like to be able to control how the square wave and the sine wave interact in terms of constructive and destructive interference. And I want to do this so I get different shapes and they have different sonic artifacts. So the way I do this is I need to add a bunch more sliders for the phase. So I'm going to add a slider 4, and that's going to be the sine phase. And I'm going to go from 0 to 1, starting at 0. So 0 means no phase shift, and 1 means a complete phase shift, which I think in the case of all these functions that are periodic amounts to the same. So we can go all the way from one cycle to a phase shift that takes you to the next cycle. And I'm going to give you a precision of 0.01 as well. So this is going to be the phase shift. And I'm going to have similar controls for all the other shapes as well. I do want to have a space between these two, so I will shift everything forward. So do I want the phase shift to come right after the width? No, I want the phase shift to be the last thing for each section. Or maybe right after the mixer. So yeah, I guess that makes more sense. So I'll have a slider 7 that is the square phase. And it will go from 0 to 1.1. Okay, so I'll do the same for all the rest of them. Now let's actually use these variables to do the phase shifting. So if I take the square wave and now it's destructing, right? The interference is destructive. You can see that the shape gets smaller. But if we do a phase shift, then we will not be changing the frequency. That's important to mention. If we bring in the tuner, we'll be able to see that shifting the phase doesn't change the frequency in which we are oscillating. So the sound will have the same pitch, but it will have a different timbre. It will have different sonic characteristics because what was destructive interference will shift into being constructive interference and vice versa. So the shape of this will be different. Anyway, let's go to the part of the code where we are actually doing we are calculating the samples. And what I need to do here is to change this cycle accordingly. So the cycle needs to be shifted, and here the cycle variable is where in the shape of the wave we want to be. And I want to do that shift, but I want to make sure that I'm still between 0 and 1. So cycle is a variable that is between 0 and 1, and all these phase variables are also between 0 and 1. And when I add them together, I want the result to be between 0 and 1. So to do that, I'm going to apply a similar trick to what we did here. We add 1 to the cycle, but then we do this. We check if the result is greater than 1, and if it is, we bring it down so that it is between 0 and 1. That's what we need to do here, and we will need to do this in several places, in all these 4 places. So I'm thinking if there is a way for me to extract this somewhere else. And yeah, I think there is a way to do this. And I think it's now time to bring in functions into the mix. And we have talked about a lot of audio effects, and we never had to introduce functions. But now is the time, I think. We will have a function that does this trick, that wraps variables around. And then we will use that function here, and we'll use it here and there and as well. So let's see how to write a function in JS effects. I think that the best place to put a function is in the init block, because if you put a function in the init block, it's available for all other blocks of code. While if you define a function in the sample block, for instance, it's only available in the sample block. And we are only going to use these functions in the sample block for now, but I anticipate that we may need some of the functions we are going to define. I guess we are going to define a bunch of them. So I think we'll need those functions in other blocks as well. We'll see. So I'll define a function, and I need to call this something. So I will call this wrap around, or maybe just wrap. And it will wrap a certain number, because yes, we are wrapping cycles here, but we could be wrapping anything. We're just wrapping a number, and we don't delimitate functions with square brackets, with brackets, but with parentheses. And now in here, we say what the function should return. So if the number is less than or equal to 1, then return the number. Otherwise, return the number minus 1. So this function wrap should not change 0.5. 0.5 evaluates to 0.5. It should not change 0 or whatever, okay? It should not change the number 1, but it should change 1.1. It should be 0.1. Okay, so this is wrapping around. Perfect. Now that we have this, we can say that the cycle is, here after doing this, the cycle is wrap the cycle. Or maybe we were using plus equals here, so maybe we could say something like this. Oh boy. Okay, there we go. So now we could say something like this, cycle plus that, and then wrap around. So with that in place, and we refactored the cycle calculation here just because we could, but the intent is that we'll be able to use these cycles here shifted and wrapped. So let's first, I'm going to first put them in parentheses. Then I am going to wrap all of them. Or actually, I'm going to first add. So here I am talking about the sign. So I'll say sign phase. And then I'll do all of them accordingly. And now I will wrap all of them using this function to guarantee that I am between 0 and 1. Okay, so let's look at the result of this. I still have the same parameters. I can bring the square wave here, and I can do some phase shifting, which changes the characteristics of the wave. Isn't that super interesting? Let's look at the thing without any other wave. So we have just this wave here. And as I shift, you don't see much change in the oscilloscope because the oscilloscope is running. But what this is doing is taking the wave back and forth. And when I have a square wave in there as well, I can shift either one and it will change the way that destructive and constructive interference occurs. So this is going to give me all these weird shapes. And as I said, when you go to 1, you wrap around to the next cycle. So the difference between 0 and 1 is absolutely nothing. You can see that there is all these weird shapes in between, but when you go from 0 directly to 1, the shape stays the same. And then we can get super weird about the way we combine these shapes. We can put some amount of the square wave with some phase shift, so it looks like this, and then some sawtooth right in there, and I can barely see it, but it's changing the shape somewhat. And then you can do some phase shifts on that, and it's getting pretty complicated. It's getting way out there. So yeah, I think this is super interesting, and I want to give it a listen. So I'll bring down the volume way down. I'm going to zero all the parameters. And then what I'm going to do next is unmute. I will also plug in my headphones, and I will unmute, and I'll keep the volume down. And now let's change the shapes. So I zoomed in there in the oscilloscope. It doesn't make the sound any louder, but we are able to at least see the wave better. So this is super interesting. When it gets rounder here in the middle, when I'm doing the phase shifting right here in the middle, it gets very round. So there is still some component of the square. You can see that there are straight lines here, straight vertical lines. There is still some amount of the square wave in there, but because it is mixed in that way, it sounds more siney. It sounds more like a sine wave than when it is right here, and there is all this destructive interference going on. So I really like that. I guess if I put 100% of the square wave, then this effect will probably be even more pronounced. It goes from very squarey to then siney and then back, if those are terms you can say. Anyway, up next, what I want to do is to have some way to see the shape of the wave. So I'm talking about these shapes over here. I am using the oscilloscope, and the shapes are moving around left and right, and you can see sometimes the left and right channel blinking because you see some red in there. And the shape, I have to zoom in and zoom out and find the right amount of samples to show so that I can actually see the shape of the wave. What I would like to do instead is have a visualization in the tone generator itself, also using this part that is a graphical user interface, but I want to plot the shape of the wave that I'm currently producing. First of all, I will need a new section of code, and I need to define some amount of screen real estate that Reaper will try to give me if there is enough screen for it to do that. So maybe 400 by 400. Let's see if that looks good. So I guess the way to test this is to reopen the effects chain. And then when I come here, well, it's not showing because I don't have any code. Is that why? I don't know. Let's see. So I have some amount of space that I want to take, and I'll just say GFX set 1 and then GFX string draw. I think it's actually draw string. Okay, I checked the documentation. It looks like this. This is different from when you're writing video processors. The API for Reaper is all over the place. Okay, I should be seeing some outputs here. Okay, I am not seeing the string that I just drew. What if I just have some... First of all, is it generating a screen of the right size? I don't know if this size is good enough. Okay, so what I just did there is I set some coordinates and then it's printing in the right place. And with respect to the size, I have no idea if it's good enough. Reaper doesn't seem to want to allocate that space for me. Or maybe it is, it's allocating, I don't know. I'll make it smaller and reopen this. Nope, it's too small. No idea how to force it to actually try 400 by 400 to see if it's good. Maybe if I add a new instance of this effect. No, not the oscilloscope, a new instance of the LFO. There you go. So yeah, guys, this is the best it can do with my screen size for 400 by 400, which may be too much. So I guess I will do like 400 seems to be okay with the width, 200 height. So that's what I will go with. I will go with, oh, I need to reopen this and I need to remove this instance of the oscillator. Okay. So now I'll say that this is 400 by 200. I get rid of all of these and then we can start playing. So what I want to do is similar to what the oscilloscope does. I want to go through the wave. But in this case, in the oscilloscope, we had to store samples in a circular buffer and whatnot. In this case, I don't have to do any of that because I already have the functions here. These are the functions that produce the shape. And I have all the variables I need. All I need is just really to traverse that function from 0 to 1, because I know that these functions go from 0 to 1. So I'll traverse the function from 0 to 1 and I will plot it. And that's all that I need to do. So first I need some x. The x is my current position of plotting, so I will call this plot x. And it will start with -1. It will now loop to traverse every column in that space. So every column in here in turn. So what I need is to go, the number of times that I need to go is this. I need to go GFXW, that represents the width of the window. That's the amount of times that I want to go through this loop. And each time I go, I want to say that, which increments this variable. Now, I want to plot something. I want to plot essentially a line that goes from this to the next. Okay, so from this x to the next, or from the previous one to here. I guess I will go from the previous one to here. And since I am doing from the previous one to here, I don't want to start with -1. I want to start with 0 so that the first time this goes around, plot x is equal to 1. And I also need to set the cursor. So I have like this pen that is drawing on the window. I need to set so that it's at x equals 0, and on the y-axis, I need to set it to a particular place. You know what? I may not even bother with this because I don't think you will be able to see the difference. One thing I do need to do is to set the color. So I want to plot this in white. 1 represents white and 0 represents black, and things in between represents shades of gray. So now that I have the x, I need to figure out the y. And to figure out the y, I need to do a computation that looks similar to this. Except that I don't want to do the amplitude. And the sum mix is actually something that depends only on these mix variables that are defined in a slider, so I can do that. And now this sum mix is available here as well. Well, it was already available here anyway, but I think it looks better if I do it this way. And I will need to do a computation that looks very similar to all of this. So let's start with that, and we'll see where we can go. So I want to GFX line, and draws a line from x and y to the other x and y. I wonder if there is a function that just takes the current cursor position for drawing. Let's check that. Yes, there is. It's right here. It's GFX line 2. So I can just say GFX line 2. The x will be my plot x. Or actually, since I have this plot x thing, it could be my GFX-X. How about that? We are using GFX-X as our loop variable. Super interesting. And then when we say, well, what x do I want? I want that one. Oh, actually, no. That will change my x before I'm even able to draw to that position. So no, I need that plot x there, because I don't want to increment my GFX right away. I want line 2 to increment it for me. So I'll do plot x. And now we need to say what the y position is. The y position is this. Well, it has to do with that. So that gives me something to work with. Cycle is the variable we used here when finding which part of the function to plot. But in this case, I don't want to use the variable cycle. What I want to use is plot x. But also, I don't want to do exactly this because I want the middle of my screen to be 0. And then this will produce something that goes from -1 to 1. And I want 1 to be the top and -1 to be the bottom. So the first thing I want to do is go to GFX height divided by 2. That's my middle line. And then I want to subtract essentially this much. So half of my screen multiplied by this. So this will give me a number like 1. So 1 times half of my screen. And then you subtract from half of my screen, I will get to the top of the screen. And if this is -1, then I will have minus half of the screen. Minus and minus combined gives me plus. So I'll have half the screen plus half the screen. And that should give me the bottom of the screen. Okay, I saved this. And now let's look at the shape. And it is just a line. That's not what I expected to see. Let's figure out what's going wrong. Oh, so what's going on here is really simple. This plot x is a number between 0 and this. And I guess since I am doing this hack, I'll start with -1 anyway. The hack being that when I start with, my GFXY is not in the right place, but I'm still drawing a line from the wrong place to the right place. And I don't think you are able to see that because it's right here on this margin. The problem is I have the plot x variable, which is a number between 0 and this. And when I'm using it here, I expect it to be a number between 0 and 1. So what I need to do is divide everywhere by GFXW, which is the boundary of my loop. So now I have this, and this is similar to this shape, so it's getting there. And there is a line here which is wrong. And if I change this shape, if I make it just a sine wave, then it works. It doesn't look at my output in dB, and if I introduce more or less of the sine wave, this is still a pure sine wave. But when I introduce the square, then it gives me the shape, and I can also do a phase shift. And you can see now, oh, I guess you can see that even with just the sine wave. Now you can see the phase shift. So the shape of the wave is moving like that. And I also want to prove that I did not introduce any problems with respect to the tuning or the frequency. So just bringing a retune really quick. So if I am producing 440, I should be able to change this. And I should be able to introduce new shapes and move them like that. And the frequency stays the same because the frequency is set here. The shape of the wave may be different, but this number is still the same. Perfect. Oh, and I just figured what the problem was with that weird line in the middle. Well, I didn't exactly figure out the problem, but I figured the solution. I just reset, before I even start drawing, I reset the pen to the origin. So I'm putting the pen right here, and then there is, I think I can maybe zoom in and you'll be able to see that there is a line going from the origin. It's a white line going from the origin down here. But it's such a small glitch that I won't really fix it. The solution would be to just maybe copy and paste this into here to set the Y position. The X position would be 0, but the Y position would be this whole mess. And then we would have the Y position set right for the first pixel. But I think this looks fine. I can do a phase shift and can barely tell that there is this extra line over here. So I'll leave that bug in there knowingly. What if I do no square, no sine wave, just square? That doesn't look awesome, does it? Because it's touching the top and the bottom. So what I will do instead is, instead of dividing by 2, which gives me half of the screen, I will divide by like something like 1.8. That doesn't work. So what if I go to 2.2? That works. So now what I'm doing here is I am leaving just some room on the top and on the bottom, so it looks better. Even when I have a square wave that should be touching the top and the bottom, I can still see what's going on there. I can combine this and I can put some sawtooth as well. What does the sawtooth look like by itself? That's a question I have. It doesn't look great. It goes from bottom up. So maybe I should leave some space in the beginning and end as well. And the way to do that is to just, I will set this to another number, and then I guess you may be able to see the glitch. But let's see. So if I set X and Y to 10, and then I will not go from -1, I will go from 10, and here I'll say -20, and here I am going to leave it like that. So now we have some room here and there. And this is more or less fair that there is this line here, because that's what the sawtooth looks like. You know what? I don't like where this is going, because I have this number that is the padding all over the place. So what I'm going to do instead is just the plot X, it needs to be between 0 and that number. Well, not really. I want the number between... Oh, I'm so confused. You know what I want to do? I want to clean this up in many ways. I think this is looking terrible, and there are many things that are wrong. Like, I would like this to probably be going up and then a line here, because it's a sawtooth down up. So it goes down first. I don't know. Anyway, there are a few things that I want to fix. The first is this. I have repetition of code here and then on this section. So what I would like to do instead is define a bunch of functions to extract all this information, and then I can reuse that in both places. So that's what I'm going to do next. I'm going to extract this into functions. So I'll have a function like sine, and it will receive the cycle position. So I'll just call this cycle. And I will bring this formula into here. So cycle and sine phase, and the sine phase is the same, so I don't want to receive that as a variable, but the cycle is what's going to change. When I call it from here, it will be cycle. When I call it from here, it will be, I don't know, something like this. Anyway, so I want the cycle to change, the phase to remain the same, and the mix and the sun mix, yeah, those are all still the same. So now I'm going to repeat this process for all other shapes. Okay, so I finished the extraction, but before I even use this, I realized something. I'm always doing the division by sun mix at the end of all these portions of the addition. So what I could do instead, or at least I think I could, is extract or factor this out. So I'll bring this down here, and now we are looking at really what the shape that we're producing over here. I won't even look at the shape that we have over here on this one. So let's try to do this. So I'll take out this division from all these parts, and I will divide here. And it still looks like it's working. It's doing the thing and mixing all the shapes, not making the wave any bigger, never bigger, sometimes smaller because of destructive interference, but never bigger. So I guess this is kind of working, and it simplifies our function a bunch. So now we can have all this sun mix go away. And I think it's fair that we extract these parts. We don't want these parts in the functions themselves. We want the functions to return just the pure mathematical thing that defines the shape of the wave. And then when using the function, we will have to do the multiplication. So now the function is only doing this part. So now we can call sine of cycle. And I will remove this part. And I will just bring in the sine wave. And when I save, it's still the same. So this is producing the right thing. And now I'll do the rest of them as well. I just finished that and it's still looking the same. I can bring in different shapes and it's reacting correctly. So I bring all of them down except maybe for sawtooth. And it's a sawtooth. Perfect. There are a few more things that I want to change. The phase shift, it has to do with the cycle, but I think it's cleaner if I do it right here instead of there, because this is not part of the mathematical definition of a sawtooth. So I will bring all these pluses down to here, and I can do that because cycle is only used along with the phase shift. So that's something I can do. I'll bring them down. And when I do it like this, it may seem like I'm just moving things around for no good reason, but look at how the function is defined now. This is the exact definition of how to take a number between 0 and 1 and turn it into the shape of a sine wave, or a number between 0 and 1 and turn it into a shape of a square wave, and so on and so forth. So I think it's fair that we are doing this because it gives us the pure definition of the thing. And since I have it now so clearly in front of me, there are a few things that I would like to change. For instance, I think that the sawtooth up and down can be better defined. So let's just bring in the sawtooth up and down. It looks like this. This is working. And now what I would like to do is, instead of doing this multiplication at the end, I can just reverse the definition of down and up. And down up being this guy. I tried to do this on the last episode and I got it wrong, but I think that now I can do it. Yeah, so it still looks the same. So I got that one right. And now we can have just these pure definitions of what it looks like to have a cycle and turn the thing into the shape of the function. And now that we extracted this into functions, we can reuse these functions over here. So I will refactor this part to do it. And the next thing that is sticking out to me is that this portion is a lot like this portion. The only difference is in this variable here instead of cycle. So I will extract yet another function that I will call just wave, and I'll pass it the cycle, and it will combine all the waves like so. Even the part that does the division by sun mix is still the same, so it will do the whole mix of the waves together. So that's what this part is going to do. I'm going to reformat this a little, and I think I'll be good to go. And now let's try to actually use this wave function that I defined. So it replaces this whole thing. I can just call wave of the cycle. And this is the part where I'm computing the samples, so I can look at the oscilloscope to check that I'm doing the right thing. And when I save, it still looks the same. I can bring in other functions and it still works. That's excellent. But now I can reuse this wave thing over here, wave of this. And I can get rid of all of that. And that makes me super happy. Let's check the graphical user interface for the plugin, and it's still doing some weird drawing here, but it's doing the thing that we want more or less. So now let's fix this final mistake and we'll call it a day. So the way I'm thinking about doing this is to have a plot width, which is the width of my window. And I'll just give some paddings around the thing. So maybe a pad of 10 pixels will be good enough. So a pad of 10 pixels times 2, because it's one on each side. One padding on each side. Maybe I can define a padding that is 10 pixels. And I will have 10 pixels of borders around, or padding around the graph. So this will be minus the padding times 2. And I will get rid of this for now. So now what I'm doing is, to recap, setting the color to white, defining a padding, and I guess I want to define the padding as a constant of sorts, so it will live here. And then I will define the plot w, which is also kind of a constant, so it will be here. And I will also need the plot height, which will be the height of the window minus the padding times 2. And then the plot x will not go this much. It will only go the plot width. And in here, so this remains the same. It will go from 0 to, well, you know what? I'll say also there is a variable here called the plot cycle, which is the plot x divided by the width. And this is actually the variable that I want to pass. So that you can see that the formula is almost the same as this one, except that this one was doing with the whole graph window, which is not what I want. So what I'll do instead is just this. So this is the plot cycle. And now I will draw a line to the plot x. Not really. I want to draw a line. So the plot has a padding to begin with. Maybe it's better if instead of saying plot x, I will say just gfx x plus 1, which is the amount that we are incrementing here. So it will go 1 pixel to the right. And with respect to the y-axis, this is the height of the whole window, but I want the height of the plot. So I'll do it like this. Or actually, I want to draw in the middle of the screen. So what I want in this place is actually the middle of the real screen. And this will be minus the plot height divided by 2 now, because that 0.2 was just to add a fake padding. And I'll multiply by the plot cycle, the wave. This is going to be a number between 0 and 1. So this should be about right, but I think I will still see some artifacts. Doesn't show anything. Ooh, okay, so I just had the coolest idea. I think that the problem and the reason why this isn't plotting anything, it has to do with the setup of gfx, x, and y before I even plot. That was the problem before, and I still think that it's the problem now. And I had removed just now the gfx, x, and y. So gfx, x starts at padding, because there is a padding on the left. And gfxy, I had an idea for what I need to do with gfxy. Remember that this is a cycle, right? So I'm plotting a wave that repeats. So what if, to begin with, I put the y at the end? So I put the y at where wave is equal to 1, or the wave at 0.1. That is the end, where it ends. So if I do that, then it's going to start at the end, and then it's going to do the cycle. So I had that idea. Let's see if it works out. So what I want to do is a computation similar to this, right? I want to go to the middle of the screen. That's this. I guess I can even extract it to another one of these constants. So gfx height middle is gfx height divided by 2. And then I can use that here. Height middle, and height middle. So that's the middle of the height, the middle of the screen on the vertical axis. And then I subtract the height of the plot divided by 2 and multiply by the plot, the wave at the number 1, which is where it ends. So this is going to set the cursor that starts drawing at the place where the wave ends. And then I'm going to see if I'm still using this in any interesting way. I don't think so. So I guess I can inline it again. Yeah, I know I'm going all over the place with these extractions and inlinings, but I think it makes sense. And now look at that. We have something on the screen again. And if I bring in different shapes, then it works like that. You can even see that the shape ends here. So this line goes from there to here. Oh, I guess it may be nice to have another corresponding one here. And it's not that hard to do. All I have to do is the cursor is already right in the X position because it was left in the right position. The cursor was left in the right position by this part. So all I have to do is just remain where I am in the X axis. And in the Y axis, I have to plot this again. But this time, I will plot this So I am at the end, so I'll plot what happens when I am at the beginning. So now let's see that. So yes, there is a line here now. And now this looks like what you would see in the oscilloscope more or less. And the proof that this works is if I take out all the shapes, but then I have a sawtooth, it kind of looks right. Yeah, so I'm not sure if I like this line. Maybe I don't like it. I don't know. Also, yeah, so I don't know if I like the fact that there is this line over here. So maybe I don't like this line at all, after all. So maybe it's best if we just leave this one on the left, but not the one on the right, because then it looks like the letter N, and I don't like this. I think I prefer to just have the one on the left. So I'll remove this one line right here. And now I have like the thing you would draw on a board if you were to show the shape of this wave. So that's a sawtooth down, up. That's a sawtooth up, down. That's a beautiful square wave. Not really. It's not beautiful. Yeah, you know what? I kind of like that line over there. So now this looks like a full typical square wave. Perfect. Full typical sine wave, square wave, sawtooth, sawtooth. And now some weird combinations of all these shapes taken together. Okay, I think that was a lot for today. I will wrap this up now. Thanks for watching this video. I hope to see you on the next one. Make sure you subscribe because I'm going to revisit this oscilloscope. I still want to have controls for it to be a honest to goodness LFO. So I will have other sliders to control the frequency, and I may revisit some parts and refactor this because the code still has some repetitions here and there that I would like to get rid of. In particular, the part that is calculating the middle of the line is all over the place. It's in 3 places in the code. So I will revisit this. Make sure you subscribe and keep watching these videos. I hope you're liking them. I see you on the next one. Bye.